And this was our details. So this was my guide which I made, and I think this is the last session we were doing for the AutoDock. What we did in that particular session, let me explain it. We opened what we selected acetylcholine esterase actually. So this file that will be for acetylcholine esterase, let me show you where we put actually our files. So on the desktop, I made a folder named as the docking. So I download these two files, PDB IDs 7E3H and 4MOE for the docking. Both of these are acetylcholine esterase. So in the first go, if you remember what we did, we opened the file in PyMol, and then we checked that either it contains one or more chains, either it contains water or not. And afterwards, and how we check that, I think you people will be practicing actually the PyMol, that how it works. So better if you use the mouse, and then it will be better for you people. So we got here two chains, and here if you can see these red dots, actually these are the water molecules. So I'm repeating the preparation. These are the buttons which are important in manipulating the files. If we go to A is for action. So here you can see you can open multiple protein files here. So we have opened this particular file. I can show it, I can hide it, I can show it, I can hide it. And then if we select certain amino acids, particularly here, then we can see it here. And then uh, in actions, if you go, you got a lot of options, like you got the zoom, you got the orientation, you got to center it, and then origin and many things here. But what we were with the concern was that I think internet is a bit unstable. We are back. So if I go to action, here are certain things. Remove waters. If you go to remove waters, here you can see red dots. These are disappear. So one way of removing the water is that. While the second thing is that if you go to sec or the sequence, in the top you can see here multiple amino acids which are present here. So in the start when we opened our file, here are the red dots were present, and even you can see them here in these particular files. So I have removed the waters. Now I can see here two chains. One is A chain, and I've moved further. Here you can see chain B. So there are two chains. One way I told you that if you click here and then pressing shift, if you press here, you can select the whole chain like B chain, and then you can remove it. So this is how we remove the chains, and these things, these ligands, these are not required. So you can select them and then you can delete them. So this is one way of doing that. But when you will get somewhat familiar with PyMols, then what you can do actually, then you can use this command prompt of the PyMol. For example, if I say it, remove chain B. So if I got here chain B, I will write down remove chain B and I will press enter. Here you can see remove chain B command has removed this chain automatically completely. Okay. And then I will press orient and this will be oriented in the middle. So this is how you can remove different chains if there are multiple chains like B, C, E, F, G, and then instead of selecting amino acid sequence, you can use the command prompt. So this is how command prompt is even better than the other ones. And then again, if you want to remove waters, you can remove waters. If you want to remove organic molecules here, you will just these ligand molecules, you will press remove org, and then what you will do, you will press enter. And here you can see with the single command, all of these organics, these are ligands, these are all removed. So these are some kind of, you can say, the commands which just make your life easier that just only a single command. So this is the power of command prompt. And therefore, we have started our work to know that how these command prompts they work. And if you wanna go and become the master of this PyMol, you need to learn the different commands of PyMol. But although we have here these commands which you can use, so here chains are removed, which are worth extra, water are removed, organic molecules are removed, and this protein is now ready. You can go to file, and then you will go to export structure, export molecule, and then you can prepare it. So then you can just save it, and then you can give it any name by selecting here PDB. So this is important because if you will not select it, you will not go forward in docking. You need to give it a name. For example, I will say that this is receptor receptor 2 because 1 is already saved here. I will select PDB, I will say it save, and it will be saved. So receptor has been saved in that particular form. So we don't need PyMol now, we can just shut it down. Okay, this is one way to prepare the receptor. The other thing how we can prepare is the using the AutoDock tool actually. So I'm just removing these previous molecules so we can go through very quickly in this session. Okay, in PyMol, it's very easy because PyMol is not a heavy program. AutoDock tool sometimes in few computers it causes some problem. So if you remember that how to run AutoDock, I have told you go to Start menu, and then here you will type AutoDock tools, and then you will just start it, and AutoDock will be started. So this is second version. I don't need second version actually, but I wanna tell you that after restarting AutoDock, you will go to File, and then you will go to Preference, and then you will set your folder in which you are doing the docking. And here is startup directory. So this is important. Every time every file will be saved in that particular startup directory. So how you can copy and paste this path actually, you will go to this folder, you will just press here on the side, and this address, you will just say it the copy, and then you will be back here in AutoDock, and you will paste it here. And then you will ask it set, it will automatically set it. Okay, the other parameters which are present here, here are the number of undos that you want to undo something. And here is a cache that if you wanna store a lot of PDB files, then 100 MB is a cache, 100 MS file you can store. I don't need you people to change any of thing, but you want to change. And then AutoDock tools, ADT. If you wanna change these things actually, these are actually for different things like PDB file writing, and these are for the interaction VSP things and histograms. For now, we don't need them because the analysis we will do that is on PyMol. If we want to do the analysis on AutoDock and we have just only one option, then we will use AutoDock tool. Otherwise, we will not touch that. And then these are the accessory tools like the viewer and deja vu, and we are not going to use it. That's how they will work. So we are concerned with journal thing, and especially with startup directory, we need to set it. Okay. If you make it default, then every time you this folder that will become your default, and you put your things inside, and every file will be there. Okay, then I will just cross it. Whenever I go to read molecule, and I will ask it to read my molecule, here are different files which are appeared. So this receptor 2, if you remember, we have prepared, but now I will show you that how you can even prepare your file by using AutoDock tool. So I have opened a file which was directly downloaded from PDB 7E3H. If you just click here, you can see here are the A, B chains in which proteins are present, and CD in which organic molecules like N-acetyl glucosamine, these are present. Okay, and very easy. You will go there, and then you can just do a right click, and you will go to here in this site. Okay, do remember this particular thing. This is used to hide and to remove the things. But if you want to delete it, you will just go there, you will select it, it will yellow highlight it. And then if you go to here, particularly edit, you can ask it to delete different things. For example, if you want to delete the molecule, you can delete it here. If you want to delete selected atom, it will just delete the selected atoms. And if you want to, it will ask you, you want to delete it or not. If you say delete it, it will be deleted. Oh, maybe I've selected the whole molecules actually. I don't want that. Okay. So here it is. I have just opened it again. So I have got these few things. This is chain A, chain B. You need to be very careful because I think space is very close to each other. So if I just make it big due to resolution on the Windows laptop, therefore I don't like Windows. Anyway, if you go to this select button, this is for selection. I select this, I select this, I select this. I have selected these three things, and then I will go to edit and I will ask it edit, delete, delete selected atoms. It will automatically delete only the selected atoms and not all. I don't think so. It's working here. Maybe it's causing some issues. Therefore, I usually don't prefer that you use the MGL tool for the preparation of molecule, because what it's giving here, it's giving an error in the viewer framework and in the library which is present here. We can correct that file actually by giving the pathway and copying the pathway here, but I will not prefer you people that you can go there in this particular file and open this VF file and change this one, the commands, but I don't want you people to do that. So what we need to do, I will prefer that you go to that particular uh, thing. I will check that why it's on my Windows, it's causing some problem because I have selected the things, but it's not deleting it properly. But you can try it maybe on Windows 11, it causes some error, or maybe you have to do it one by one. You will go here and then you will select if we have selected that, and then you can go here. But let's try with waters first, that if water is being deleted or not. So waters are being deleted, so it's not even catching the things, it's not even opening the molecule. So I think it's caused some error, some problem. Let me restart AutoDock, I think, because sometimes what happens that if it causes the error, it doesn't show anything here. And with the mouse, you can orient it, but I don't have the mouse here. So let me reset the view if it helps. Otherwise, I just need to do a restart. So here you can see that we have put 100 redos. We can do the 100 redos, but we cannot see the selection here in the display window. So there is something which is inhibiting it. So let me restart it. So in AutoDock, sometimes it happens. For that purpose, what usually we do, so it's halt. So what usually we do, I always do docking for me, which is only the command prompt base. Because, and this is the only reason that we started all the work from the Python and from the command prompt. Because the next thing I want to tell you in the next session, I hope so, that how you can do the docking and virtual screening by using on the command prompt, and you will get all the errors in the command prompt actually, and there will be no error here. So let me open this molecule again. I will open the similar one, the same one actually, and then we can see here also the errors, that what kind of error it's giving us. So then we will check that either here is problem in our system library or in AutoDock itself. So I will select this, and this, because this is the special button which is for selection. Then I will go to edit. I will go to this particular delete thing, and I will ask it to delete the selected molecules, selected atoms. So I will So this is also atom command. So it should delete only this molecule. But if it's still doing something wrong, then I will prefer that you people don't use the AutoDock actually, but let's try it. Okay, it works now. Restart, it helped. So we got here only the chain A. So be careful in that. You should be very careful in that you are selecting what you are selecting. Sometimes what happens that this graphic user interface is a bit dodgy, that you select this one, the other molecule automatically selects. So you need to be very careful here. So if we look at the guide, what you need to do, that we need to open read molecules, then edit and add the hydrogens. So you will go to here, you will go to hydrogen and you will add the things. And here it's telling us that where the hydrogens, they are present in the non-bounded form, you want to add them or not. So it depends on you people. Oh, okay, there are still water molecule, it's saying. So let me just off it because we haven't deleted the water molecule. So I will go to edit and then I will ask it delete water molecule. So water molecule is now deleted. I will go to add, then there are hydrogen, and I will ask it to add hydrogen. And here you can see it asking me what kind of hydrogen you want to add. Usually we add the hydrogens which are only the polar ones and not the other ones. So we have just added the polar hydrogens here, and then I will ask it, okay. And then I will go to the file and I will ask it, okay, save my molecule. Okay, here are many options. Sometimes if you are very busy, then you can go to save and you can save your current session. So you have done your work by this time and then you want to do your work in the next week, in the next day. So you can start it from here, from this same position that you are working on. So it has option of that you can save the session. Now you can save it into different form. You will save it into PDB, into PDBQT. So PDBQT, if I save it in PDBQT, we haven't placed charges on that, remember, because Q is for the charge thing. If I directly save it, it may get us error. So what we will do, we will go to file, save and save PDB first. So this is PDB and where it's saving in that particular name and it's okay. It's already exists there. You want to overwrite. Yes, I want to overwrite. So my file that will be overwrite and that will be in this position. Hydrogens are visible here. And if you want to apply the charges, you can apply that. So it depends that if you want to apply the Coleman's charges on that or not. If you want to apply that, you can add also. So these charges, these can be added, but then you need to again save it into the PDB by the same name. Yes, save it. So this is how you save the PDB. And then if you want to go to your next thing, so these are the things I want you people to play with these different options. If you want to go to ligand, you get to output, you will open it, and then ligand is our ligand. So I will open it. It said, okay, these charges are added, these are the aromatic carbons, you want to do it, okay. And then here are certain options which I gave you, that torsion trees, these are added. So torsion trees, when you add here, it gives us different options. You need to choose the root of the ligand. So let me hide this one so you can see only the ligand molecules. So if you go to ligand, torsion tree, choose the tree. You can choose the root, but I will prefer don't use it now because you are not that much expert. Then what you need to do, detect the root. You can also then after detection the root, what you can do, you can check the torsion tree and then you can ask it choose the torsion or set the number of torsion. If you ask it to choose a torsion, it will automatically select it for you people. 6 out of 32. If you want to do any of these things, then you can make it and you can make these bonds rotatable or not. So it depends that what kind of ligand molecule is present here. And then you will just done it. Okay, and if you wanna go here torsion tree, if you wanna set the number of torsion, you can set it. So I will prefer that in some ligands, if the number of torsion are more than 6, you should put it to the 6 and then you will ask it to dismiss. So this is another thing, that if the torsion angles in your ligands they are more than 6, you have to restrict it to 6. And then you will go to ligands, you will say output, save the PDB-QT with the same name. You will save it because we have already saved it. So it will ask you to replace it. Okay, the next thing is so just play with these things. Flexible docking we will do on Saturday. I will let you know that how you can prepare the file for the flexible docking. For now, we will do the general rigid docking. So here are different files. If you go to grid, you need to choose the macromolecules because it's already open. I will select it. And then if you wanna, it has just selected, initialized it. It says, okay, if you wanna save it in PDB-QT, yes, we wanna save it. I will save it into PDB-QT file. And then on the grid, again, it asks me set the map type. Directly choose ligand, or how you wanna set the map type actually. So it also depends on you. I want you people that you practice different options. So I will choose the ligand molecule actually. I will say this is my ligand. It will select the ligand molecule. And then in the third option means you will just going by that. In the grid box, I will just turn, I will turn this on actually. So I can see that how much bigger box my should be. So I will just move this into different dimensions and I will prepare in the guide which I have prepared. I have written the exact good dimension which you people can use. So in the different dimensions, I will prefer that in the first runs, you cover everything here and don't touch these things, and then go to file, and then you can close saving it. So we have saved that how the grid maps will be prepared. Other options are the parameters library, file name. If you wanna see it, if you wanna save it, then you can save it as 1, 2, 3. If you don't wanna save it, what is that actually? If you have metal ions in your ligand molecule, then what you need to do, you need to give it a different parameter file name. But if there is no any, because we don't have, so we will not edit it, we will not do it. And then you will go to grid and then output save grid parameter file. So this is important. I will say it, okay, save it in form of grid, and I will ask it save. Yes, we want to replace it. So I have replaced it. And then if you want to see what is in grid file, you will go to edit. These are our box. These are the maps. These are the spacing. And this is how different maps will be formed. If you want to change few things, you can change them. And if you want to make it big, make it low, or do some other names, you can also, there are certain options which are in the advanced. If you want to change the grid, we'll discuss them maybe somewhere later on. Then we can write those options. Otherwise, there is no need. I will press OK. So we have prepared our grid file. We are ready to run it. I will go to run. I will say it auto grid run. So here is another thing which is very important, and what I usually do. What I usually do is that in my folder in which I am doing the docking thing, I put these two files, AutoDock 4 and AutoGrid 4. I have sent you these files, and these files are also present into your program folder. Actually, you can copy them from there. So I will go to browse and I will select what I will select. I will select AutoGrid because I'm doing AutoGrid. And then I will say it, I'm doing this grid file. So this is, here you can see it has automatically created this path, this file name, and then I will ask it to launch. And it automatically launch this particular box. Here you can see that AutoGrid is launching. And meanwhile, when it's launching, it's actually forming the maps. So it's forming the maps in the background. And I think maybe in a minute or two, it will form a map like this. So here you can see that it's forming the maps, receptor.maps like this, and it will generate the maps like this, A, C, D, E, N, O, A, means the different atoms, depending on the atom types which are present, it will form all different kind of maps here. So let's wait until it's just finishes. We can also use the maps which I have already created to save the time, but I think let us just let it go. I don't want to kill it. I don't want to stop it, because sometimes the previously made maps, they may create the issues because the receptor name was different, which I am using. So it will take a few minutes, I think, or maybe a few more. Meanwhile, I am just want to tell you that what we will do in the next. So we will go to the docking thing. In the docking, you can see here the macromolecules. It will ask you to do macromolecules. We will go to macromolecule rigid docking because we are doing. So I will select rigid docking. So we were using this receptor actually. I will open it, and then ligand, we will choose it. Of course, we have chosen this one. Then it asks us about the different parameters, that it should be random. These are the atom types, which files should be generated beforehand. And then I will just ask it, okay, for now I will ask it, I accept it. And then I will go to search parameters. Usually we select here genetic algorithm. In genetic algorithm, it asks us many things. So you can do the things which are longer, shorter, medium. For now, I will prefer longer, but here we will do the shorter because of the time. And the number of runs, it depends. I will say it just only do 5 runs. So there are a lot of parameters which you can change, but here I will prefer for now you change only these two and then accept it. So we have accepted this file actually, and then ask it docking parameters. In docking parameters, there are a number of things. You can select the libraries, you can select the PIDs. We don't need that. For now, for you people, I will prefer that you just use these user defaults actually, and just accept that. And then in the next, it will ask us about other parameters. Other parameters includes the docking parameter file. If you have metalines, as I said, you will include your parameter file in DPF and then you will give it a name. But if it's not, then you will just say it no by keeping it default, and then you will accept it. So everything is now accepted. Now the next thing is to generate the output. But in output, in the next output, we will not generate it until and unless we got something which is called this file, the GLG file, after the mapping. So it's just generating the maps. So let me check that either it has generated maps or not. So I think it has generated all the maps which we require. So here are all the maps which are present. And here is a file, which is the grid file, which has been prepared here. So it has been made. So here you can see that docking, we have discussed everything. We go to output, we go to genetic algorithm actually. In genetic algorithm, here you can see that we have already, I have already a docking prepared file, but I'm not gonna use that. I will go to docking, output, genetic algorithm. So I will do it, I will give it the same name actually, and I will save it and I will replace it. So a new docking file has been saved. This is very important that every time you save a new docking file, if you want to look at that file, what is inside, here you can see the different things, the seed time, ligand input, output. These are the maps and these are the random things. These are the RMST tools. And then you will press OK. And then now there is a time of running. We have run AutoGrid. Now we are going to run AutoDock. I will go to AutoDock. And then here I will select in the same way the AutoDock for, and here I will select which file we have created, the doc PDF, and automatically it will generate a DGL file. If you want to add many advanced things, you can do yes. Otherwise, there is no any need to generate it. And ultimately, you will not touch this file. Actually, this is a file which you usually use for the purpose to run it in the terminal, and then you will ask it to run, and a box will be open, and now it's running. And I think in a few minutes, 5 or 10 minutes, then 5 minutes, it will be run. And I hope so that I will be back in 5 minutes. We will just pausing the session here, and I will back at in 5-6 minutes until this file will be run, and then we will start analyzing this file, that how we can analyze the results of the docking and how we can visualize it. So I'm just gonna stop it here, and then we will be starting the analysis after running this file. I hope so in 5, 7, 10 minutes it will be done. And we will be back here at 6:15 after the prayer, I hope so. And then see you at 6:15.